Today's video is on 5.8, Modeling Quadratic Functions. Modeling quadratic functions is just a really fancy way of saying write the equation. Up until today, we have only written equations in standard form. We've looked at other equations, but we haven't actually written them. And that's what we're going to do today. We're going to start by writing the equation in vertex form. Before we can even get started, we've got to remember what vertex form looks like. So vertex form is y equals a parentheses x minus h quantity squared plus k. And remember, the a is determining the shape and orientation, and hk is that vertex. So what we're going to be given is we're going to be given a vertex at 6, 5 and our point at 3, negative 13. What we're going to do is we're going to plug everything that we know in. We know that hk is the vertex, so the 6 is representing the h, the 5 is representing the k. The point is just any random point on that line. This is this random x coordinate, this is the y coordinate. The vertex is a very special point that has to be in the h and the k, but along a quadratic function, along your parabola, you can have multiple points. It's an infinite number of points, and this is just one random point. So we're going to plug that stuff in. The y we said was a negative 13. We don't know the a, so that's a variable we don't know, so we leave it. The x coordinate of our point is 3 minus the h, which is 6, quantity squared, plus k, and we look at our vertex to find that, which is 5. So once we've plugged in all of our known values, we only have one unknown. So to find that one unknown, we just got to solve. So we're going to simplify, making sure that we're staying true to order of operations. 3 minus 6 is a negative 3. And then we're going to square that negative 3. Be careful. Make sure that you square the negative. A negative times a negative is going to give us a positive 9a. That number is being multiplied by the 9, so 9 is the coefficient. If we want to solve for a, we subtract 5 to the other side. A negative 18 equals 9a. Divide by 9. And our only value we didn't know, we now know. A is a negative 2. So we take all that stuff that we know, and we're going to plug it into the general form. Now we're not going to use the point because remember, the parabola is going to have lots of different points on it. Since it's vertex form, the one thing that we know from the equation is the vertex. So we're going to keep that vertex when we write the equation. So we've got y equals our a value, which is a negative 2, x minus our vertex h, which is 6, plus k, which is 5. So vertex form of our equation is y equals a negative 2, parentheses x minus h, quantity squared, plus 5. I know that's a lot, so let's do one more example before I let you go on your own. Vertex, that is your h and your k value. The point you are going to use as the x and the y. We always start with our general form, which we know is y equals a times x minus h, quantity squared, plus k. We're going to fill in all of our known values. So the y from our point is 10. We don't know the a. The x from our point is 5, minus h from the vertex. Now we're subtracting a negative, which means we're adding 1, quantity squared, plus k, and we're adding a negative 2. Again, we only have one unknown, which is our a value. So we do order of operations. 5 plus 1 parentheses come first, so that's 6 squared, plus negative 2, which is just minus 2. Order of operations say that we have to square the 6 first, and 6 squared gives us 36a. We add the 2 over. Then we divide by 36. Hopefully you did not tell me that your a value is 3. Make sure that you're paying attention to the order in which you're dividing. 12 over 36 isn't 3, but instead it's 1/3. So now we take the a value and we take the vertex because it's vertex form, and we plug it in. So y equals our a value, which we just found was 1/3. Our vertex x minus the h quantity squared minus 2. Alright, for the next one here, we've done 2 examples together. I want you to press pause and see if you can get the next one all on your own. Just remember, you're going to first start by solving for A, and then you're going to plug that and the vertex back into the general form. Alright, press pause and go at it. Alright, let's see how you did. The first thing you should have done is solve for your A value. We start with vertex form. We plug in our x, our y, and we plug in our h and our k. From there, we follow our order of operations, and hopefully you got to the point where you found that A was equal to 1. From there, we plug our A value in, which is 1, and I'm sure some of you are sitting there thinking, no, you do not have to write it. If the coefficient is a positive 1, then you don't have to write it because it's assumed to be 1. Just like on the x, we know that that exponent there is a 1, it's just assumed to be 1. And then we plug in our h and our k. Just remember, every single time you write vertex form, you should always have an x and a y in the equation. That may help you remember that you're replacing the h and the k. So there should always be an x and a y in your answer for vertex form. Alright, the second one that we're going to look at today is writing the quadratic in intercept form. And we know that intercept form, we're able to see what our intercepts are. So the general form for that is y equals a times x minus p times x minus q, where p and q are those x-intercepts. So I'm going to tell you that your x-intercepts are -1 and 5. And then I'm going to tell you a point. And we know that just like above, the point is the x and the y. Anytime you have intercepts, those are the p and q from the general form. So when we go to write this, we get our y. We replace the y with the y coordinate from our point, which is -42. The x, I missed the a. We don't know what the a is. That's what we're solving for. We have the x from our coordinate is 6 minus p. Our p is -1 minus a -1 is a +1. X minus q, our x is 6, so we're going to use that x. Notice how you have the x twice in the equation, therefore you're going to write that x twice as you're trying to solve for that a value. Minus q, and our q is 5. So once again, we've filled in all of the known information to find the one unknown, which is the a value. Again, following order of operations, we do parentheses first. So 6 plus 1 is 7. 6 minus 5 is 1. On the right-hand side, we've got 3 pieces being multiplied. And 7 times 1 gives you 7a. Divide by 7. And we find that a is equal to a -6. Alright, so we look back at the general form. And just like with intercept form, in your answer, you should have an x and a y. Those are the only 2 variables that you should have in the equation in the end once you've found everything. So as we step through the equation, we've got the y. Remember, we always have the x and the y. We found the a value, which was a -6. We have x's in our equation, so we keep the x there, minus p. P is -1 minus negative gives you a +1. X minus q, so x minus 5. Just like with any other form, we know that anytime you have something inside of a grouping symbol, just like with the absolute value graphs, just like the regular standard form for parabola, it's always the opposite of what you see on the inside. So we know that our x-intercept's at a -1, we know that our x-intercept's at a +5. Okay, let's do another one of those. So we're given the x-intercepts are p is 3 and q is 7, and we've got our point. And as always, our point is our x and our y. So as we go to fill in our general form, let's scroll down. Let's go ahead and write that again. Y equals a times x minus p, where p is an intercept, and x minus q, where q is your other x-intercept. We know the y coordinate from our point, which is -20. We don't know the a. Regardless of its vertex form or intercept form, we're always trying to find that a value. We're told that the x is 5 from the point, minus p, which is 3. And we've got that x again, so we use the 5 again, minus q, which is 7. All right, let's simplify. 5 minus 3 is 2. 5 minus 7 is a negative 2. So we've got negative 20 is equal to a negative 4a. We divide by a negative 4, and we find that a is equal to a positive 5. Don't forget, in our general form of equation, we should only have x's and y's. Everything else should be filled in. So we start there with the y. We found that the a value was 5. We've got x minus p. We know p is 3. And we know that we've got x minus q, and q is 7. So in vertex form, we had a very specific point that was part of our equation, which was the vertex. So we used the vertex twice, once to find a and once to write the equation. Since we have intercept form here, we're using the intercepts twice, once to find a and then a second time to write the equation. Make sure the equation only has x's and y's in them, no other unknown values. Alright, I'm sure you can guess what's coming up next. This is our last problem for our video today. Go ahead and press pause and try this one on your own. Okay, let's check your work. We plug in our x and y coordinate. We plug in the pink ones, which are your intercepts. We find that our a value is equal to a negative 2 over 5. When we go to write this into intercept form, we start the way we would normally do. We know that we have our x's and our y's in the equation, no other unknown values. But when we go to plug in here, we get x minus 0 since our y-intercept was 0, and minus a negative 6, so that's a plus 6. There's two ways you can write this. You can write the x minus 0 because you're very much used to writing x minus whatever that intercept is. But just know that that means the same thing as just writing x, because whether you add 0 or subtract 0, you're not changing the value of that piece. So you could just have x. So either one of these are correct, no problems either way. So if you see it that way, you know what it means. If you want to write it that way, you can go ahead. And that is all for your video today.